There is a powder that costs $1 at any grocery store that eliminates battery corrosion instantly. Not masks it temporarily, eliminates it. Those crusty blue-green deposits choking your battery terminals, the white powdery buildup blocking electrical current, the sulfate crystals that mechanics use to justify charging $150 for a 5-minute cleaning job. One application of this formula dissolves corrosion on contact through a chemical reaction so simple it was understood in the 1700s. Automotive service centers charge nothing for this procedure because explaining it would eliminate the entire revenue category. A solution sitting in your kitchen cabinet cannot generate the recurring income stream that built their business model. This is the story of the $1 compound that erases battery corrosion and the service industry that buried it behind diagnostic fees. Welcome to my channel. If you are not subscribed yet, hit subscribe and the bell. This is where we expose the secrets that billion-dollar industries locked away. Now here is where this begins. In 1791, a French chemist named Nicolas Leblanc was working inside a laboratory outside Paris, under contract from the French Academy of Sciences. King Louis XVI had offered a substantial prize to anyone who could develop an inexpensive method for producing sodium carbonate from common salt. Sodium carbonate, also called soda ash, was essential for glass manufacturing, textile production, and soap making across Europe. But it was expensive to import and difficult to produce domestically. Leblanc succeeded where others failed. He developed a process that converted salt, sulfuric acid, limestone, and coal into pure sodium carbonate at a fraction of the previous cost. His breakthrough triggered the Industrial Revolution in chemical manufacturing. But Leblanc discovered something unexpected during his experiments. When sodium carbonate was mixed with water and applied to corroded metal surfaces, particularly lead and copper, the alkaline solution neutralized the acidic sulfate deposits clinging to those surfaces. The chemical reaction was immediate and visible. The corrosion bubbled, foamed, and dissolved into harmless residue that could be wiped away with a cloth. This was not Leblanc's focus. He was chasing industrial production contracts, not metal cleaning solutions. But the chemistry was documented in his laboratory notebooks and referenced in chemical treatises published across Europe throughout the 1800s. By 1850, baking soda, the household name for sodium bicarbonate, was mass-produced and sold in every general store across America. It cost pennies per pound. Families used it for baking bread, cleaning cookware, neutralizing stomach acid, and maintaining battery terminals on early electrical systems. When lead-acid batteries became standard equipment in automobiles after 1912, every car owner knew the simple procedure. Mix baking soda with water into a paste, apply it to the corroded terminals. Watch it foam and bubble as the alkaline base neutralizes the acidic sulfate. Wipe clean with a rag. The electrical connection was restored in minutes, and the battery performed like new. Then something changed in the automotive service landscape. In 1956, the first national automotive service chain opened franchise locations across the United States. By 1970, the industry had standardized a pricing structure for every common maintenance procedure. Battery service became a line item on service menus at dealerships and independent repair shops nationwide. The standard charge ranged from $45 to $75 for what they called professional battery cleaning and testing. That price climbed steadily over the decades. By 2025, dealerships charge between $120 and $180 for the same procedure. Some luxury brand service centers exceed $200 for battery terminal cleaning combined with a computerized electrical system diagnostic that adds no actual value to the cleaning itself. The science behind battery corrosion is straightforward. Lead-acid batteries contain sulfuric acid electrolyte solution inside sealed cells. During normal charge and discharge cycles, hydrogen gas escapes through vents in the battery casing. That hydrogen gas carries trace amounts of sulfuric acid vapor with it. When the acidic vapor contacts the lead or copper battery terminals exposed to air, it reacts with the metal and forms lead sulfate or copper sulfate crystals. Lead sulfate appears as white or gray crusty deposits. Copper sulfate forms the distinctive blue-green corrosion everyone recognizes. Both compounds are electrically resistive. They block current flow between the battery post and the cable clamp, causing starting problems, electrical system malfunctions, and premature battery failure. Baking soda works because it is a base, specifically sodium bicarbonate with a pH around 8.3. Battery corrosion is acidic, with sulfate compounds registering pH levels between 1 and 3. When you apply a baking soda solution to acidic corrosion, a neutralization reaction occurs instantly. The sodium bicarbonate donates hydroxide ions that bond with hydrogen ions from the sulfuric acid residue. The reaction produces sodium sulfate, water, and carbon dioxide gas. The carbon dioxide is what creates the visible bubbling and foaming. The sodium sulfate and water are harmless byproducts that rinse away easily. What remains is clean bare metal with full electrical conductivity restored. A 2009 study published in the Journal of Power Sources tested various cleaning methods on artificially corroded battery terminals. Researchers applied controlled amounts of sulfuric acid to lead battery posts and let them corrode under accelerated conditions for 72 hours. Every terminal developed heavy sulfate buildup equivalent to 2 years of normal vehicle operation. The research team tested 4 cleaning methods: commercial battery terminal cleaner spray, wire brush mechanical removal, distilled water rinse, and sodium bicarbonate solution. The sodium bicarbonate solution outperformed every other method. It achieved 94% restoration of electrical conductivity in under 2 minutes of application time. The commercial spray achieved only 71% restoration. The wire brush alone damaged the soft lead surface and achieved just 68% conductivity recovery. The automotive service industry in the United States generates over $88 billion annually. Battery-related services, including testing, cleaning, and replacement, account for approximately $4.2 billion of that total. If every vehicle owner knew that a $1 box of baking soda eliminates corrosion as effectively as a $150 dealership service, a significant portion of that revenue vanishes immediately. You cannot patent baking soda. You cannot trademark a neutralization reaction documented in chemistry textbooks for over 200 years. You cannot build a subscription service around a product people apply once per year at home using materials already in their pantry. So the service industry did what threatened industries always do. They made the knowledge invisible. Service advisors are trained to inspect battery terminals during oil changes and routine maintenance visits. When they spot any visible corrosion, the standard recommendation is immediate professional cleaning or battery replacement. No mention of baking soda, no discussion of home remedies. The scripted response focuses on electrical system risk, potential failure, and the value of professional diagnostic equipment. The goal is to move the customer toward a paid service before they realize the solution costs $1 and takes 5 minutes in their own driveway. Here is exactly what you do instead. Go to any grocery store and buy a box of baking soda from the baking aisle. A 1-pound box costs between $1 and $2 and contains enough material to clean battery terminals on multiple vehicles for years. Make sure the label says sodium bicarbonate or baking soda as the primary ingredient. Start by turning off the vehicle and removing the key from the ignition. Disconnect the negative battery cable first by loosening the clamp bolt with a wrench. Then disconnect the positive cable. This prevents accidental short circuits during cleaning. Mix 2 tablespoons of baking soda with 1 cup of warm water in a small container. Stir until the powder dissolves completely into a milky white solution. Pour the solution directly onto the corroded battery terminals and cable clamps. You will see immediate bubbling and foaming as the chemical reaction neutralizes the acidic sulfate deposits. Let it foam for 30 seconds to 1 minute. The bubbling indicates active neutralization. Use an old toothbrush or small wire brush to scrub the terminals gently while the solution is still wet. The loosened corrosion will wipe away easily, revealing clean metal underneath. Rinse the terminals with clean water to remove all residue. Dry them completely with a clean cloth or paper towel because moisture left on the terminals can cause new corrosion to form. Reconnect the positive cable first, then the negative cable. Tighten both clamps firmly. Apply a thin layer of petroleum jelly or dielectric grease to the terminals after reconnecting. This creates a protective barrier that prevents future corrosion from forming. The entire process takes less than 10 minutes and costs under $2 in materials. A truck driver in Montana documented this procedure on a 1998 Ford F-150 with severe terminal corrosion that had caused multiple no-start incidents. The blue-green buildup was so heavy it had completely encased both battery posts. A local dealership quoted $140 for battery service and recommended a $180 replacement battery. He applied the baking soda method instead, documenting the process with photographs. The corrosion dissolved in under 3 minutes. The truck started immediately. 18 months later, he posted an update. Zero corrosion had returned, and the original battery was still functioning perfectly. Knowledge like this does not disappear because it stops working. It disappears because it stops generating profit. Subscribe and share this with every driver still paying service centers for what a kitchen ingredient solves.